So we will solve for this equation also. We have the lemniscate x square plus y square the whole square equal to x square minus y square. So x square plus y square is nothing but r square, and r square the whole square is r raised to 4 minus x square, that is r square cos square theta minus y square, that is r square sin square theta. We will take r square common, we will get cos square theta minus sin square theta. 1 r square from here will get cancelled, so here we get r square equal to, what is cos square theta minus sin square theta? We all know cos square theta minus sin square theta is nothing but cos of 2 theta. So this is our r square, and r will be root of cos 2 theta. So this also represent the equation of lemniscate in polar coordinates. Okay, so these are the equation of lemniscate in polar coordinates. So now if we see, we have converted our Cartesian coordinate into a polar coordinate. So here we will consider theta and r. So here we have theta angle, which represents the angle of this curve and the distance of this curve. R is the distance of this curve from the origin. So here we will consider one strip. Let's say this is our strip, and we will rotate this strip from this point, from here to here, we will rotate this strip in this fashion till this point. So here we need two angles. Okay, here this will be one angle and this will be another angle. So we rotate this strip starting from this angle to this angle. Okay, so we need these two angles. What are these two angles? So for that we need to consider this equation. R square is cos 2 theta, then r will be plus minus root of cos 2 theta. Okay, we are taking the square root. At this point, at the origin, r is equal to 0 because x is also equal to 0 and y is also equal to 0 at the origin. So r will also be equal to 0. So the lower end of this strip is 0. What is the upper end? Upper end is on the lemniscate curve. What is the equation of lemniscate curve? It is root of cos 2 theta. So r is root of cos 2 theta. But this angle is going from origin. So we put r equal to 0 here. So we get plus minus root of cos 2 theta. Then we take the square, we get 0 equal to plus minus cos 2 theta. What is cos of which angle is 0? Cos of pi by 2 is 0. That means 2 theta is plus minus pi by 2. Then theta will be plus minus pi by 4. This means that this end represent minus pi by 4 and this upper end represent theta equal to plus pi by 4. That means that this lemniscate curve is going from minus pi by 4 to plus pi by 4. Okay, why we are not considering this loop? Because here in the question it is given we have to consider only one loop where r is the loop of the curve. It is not said that where r is the curve. If it is said that r is the area covered by the curve, then we have to consider both this area. But here it is mentioned r is the loop of the curve, so we will consider only one loop, and we will consider one strip in this way, in radial fashion. This is the radial fashion. So we rotate this strip from theta equal to minus pi by 4 to pi by 4. So we will cover entire this loop. So we get two limits, that is r is equal to 0 to r root of cos 2 theta, and theta is going from minus pi by 4 to pi by 4. So we substitute this limit in this equation, then our equation will become I equal to theta is going from minus pi by 4 to pi by 4, then integration of r is going from 0 to root of cos 2 theta r dr d theta upon 1 plus r square the whole square d theta. So r is containing the angle theta. So first we will integrate with respect to r. So theta will remain constant for now. So concentrate only on this integration. So if you see here, if we take 1 plus r square in the numerator, so we get integration of r equal to 0 to r equal to root of cos 2 theta r 1 plus r square the whole raised to minus 2 dr d theta. Just concentrate on this integration. So now if you see here, if we consider f of r equal to 1 plus r square, that is this term, then f dash of r is nothing but 2r. So here we have 1 r present, so we multiply and divide by 2. So this term will become f dash of r, and this term is nothing but f of r the whole raised to minus 2.